Hello friends. Hello friends. So, in my first video, I discussed about solving of a differential equation where we did by separating the variables. So I explained it through one question. So let's take a few questions from here. The second question that we'll be discussing is 1 minus cos x multiplied to dy on dx is under root of 4 minus y square. Now, how do we separate the variables? It's very clear from this expression that the expression converts to the form dy, and the y of the y expression on the right hand side is taken to the left hand side as 1 on 4 minus y square, and on the right hand side we have dx as 1 upon 1 minus cos x. Now the integration of this, we have a formula for the integration of d. It is under root of a square minus u square. A is a constant. The formula that we have is sine inverse. It is sine inverse u on a. So as per this formula, the left hand side reduces to sine inverse by on 2. And what about the right hand side? In the first question, I had a similar type of expression. So where I introduced 1 plus cos x divided by 1 plus cos x and had a form where we could integrate easily. Now I'm taking up the second way of that is the alternate way I'm discussing here. You remember 1 minus cos x, 1 minus cos x. We can rewrite this 1 minus cos x in terms of its submultiple as 2 sine square x on 2. So that gives us d half of cosec square. Instead of writing 1 upon sine square, we can always write it as cosec square x on 2 dx. So the integration is of cosec square x on 2. Now how is cosec square x on 2 integrated? Before it taking up, we'll have to rewrite this x on 2. It's a composite function. We have x on 2 as t. So we get dx on 2 as dt. So this expression changes to half of, sorry, it is integration of cosec square t. It changes to cosec square t dt. So the integration of cosec square t is nothing but minus cot t. Now what is this t? T is x on 2. So we have it as minus cot x on 2. After integration, we'll have to put this constant. We have it as c. So let's complete the expression. It is nothing but sine inverse y on 2. So this is a solution for the differential equation given. Now we move to the next question, that is y log y dx on dy is equal to x. So as we see dx on the numerator, let us keep dx here itself. So if we keep dx here, then the x of the right hand side come to the left hand side as 1 on x. So it's the integration of dx on 1 on x. And then the dy goes to the right side as dy multiplied by dy. So what we have in its denominator is y log y. Now the question is the integration of 1 on x. So we know what the integration of 1 on x is. It is log of mod x. Now for the integration of this expression, we'll have to go in for a substitution. The substitution we have is log y, will take it as t. So we get dy on y as dt. So this expression changes to integration of dt on, because dy on y is dt and upon log y it is t. So we have log of mod x is equal to, now integration of the same expression 1 upon t, it is nothing but log of, now log of t, t is log of y, plus, now we have integrated both sides, we need to put a constant. So as I said, it is your choice, whichever side you want you can put that constant. Since I'm writing this expression, I have sometimes I prefer to write it on towards the x side, or you can always use right side of the expression to write the constant. So I'm using this side to write the constant. So this is the answer. Now most of the time you may have the expression in a simplified way. That may be a choice that we have in the option. How do we write it in the simplified way? For writing it in the simplified way, the constant that we have can also be written as a logarithmic function. It doesn't make any difference. C or log C, it will not make any difference. Difference is we can always simplify it. How is it simplified? This is read as log of A plus log of B, and log of A plus log of B is nothing but log of AB. So using this property of logarithm, this gets combined as log of C log pi. So the advantage of this is we can always write this expression, and this modulus can also be avoided here. X is equal to C log pi. So this is a curve which corresponds to this differential equation. Fine. Now we move on to the fourth question, that is dy on dx is equal to 4 minus x square multiplied to 2 plus y square. And we can very easily convert this expression as dy on 2 plus y square, and that is 4 minus x square multiplied to dx. So we get the integration of dy on 2 plus y square. So the integration of this takes the form, it is du on a square plus u square. The answer to this is 1 on a tan inverse u on a. So as per this formula, we have it as 1 on a tan inverse by on root 2. And the right side is a simple polynomial, so its answer is 4x minus x cube upon 3 plus c. We don't need to write any simplification, we can leave it in this form. Fine. Then we have the fifth question as y square plus 1 multiplied to dy on dx. So the integration changes to this form, that is y square plus 1 dy is equal to sine inverse x dx. The left hand side, it is y cube on 3 plus y. But how do we integrate the right hand side? So if you see this expression sine inverse x, when we discussed integration, we know that integration of sine inverse x cannot be taken up directly. So we introduce one factor in it and read this expression as integral of u and v. That's the product of two different functions. It is taken up as u multiplied by integral of v minus the integration of the derivative of u with the integral of v. That is, one function is to be differentiated, the other function is to be integrated. Now, as I said, we do not integrate sine inverse x, so obviously we have a choice that we'll have to take 1 as v and sine inverse x as u. So let us apply the formula and write the answer instead of writing that in the form of a symbol. So we have the integration of v, that is integration of 1, which is nothing but x, with u constant. So it is sine inverse x minus the integral of the derivative of sine inverse x is under root of 1 upon 1 minus x square, and the integral of v, that is x dx. So let's complete the integration of this expression. The integration of x on root 1 minus x square. For integration, we'll prefer to take 1 minus x square as t square rather than t. So this changes to minus 2x dx as 2t dt. So the integration of this is nothing but the integration of t dt upon under root 1 minus t square will come out to be t. So the integration of 1, that is t. The integration of 1 is t, which comes out to be 1 minus x square. Now complete the rest of the, fill in the blank. We have the rest of the expression. It is y cube on 3 plus y. So it's y cube on 3 plus y is equal to x sine inverse x plus root this plus a c. Thank you.